commercialization. Over to you, Professor Sinskey.
Thank you very much. I want to acknowledge the organizers for the great opportunity to be here. And also I want to acknowledge my colleague, Professor Ra, for letting me participate in this program, besides carrying her luggage to Malaysia and various trips and so forth. She, as Ravi has said, is totally committed to this project, and my role in this project is to help and guide how we take the fundamental discoveries that have been made on this very interesting product and develop a strategy for quality control, for safety, and then eventually the commercialization routes. So I'm going to summarize where we understand on the fingerprints of the oil palm phenolics as to what are the major constituents primarily from the phenolic perspective. We have not characterized fully the fiber consumption or composition in this product yet. We'll talk a little bit about the safety and some literature data on human consumption of oil palm fruits, or fruit from the oil palm, and then I'm going to share with you our commercialization strategy for this product through a company called Phenolaeis, and I'll let you figure out how the name was derived. So here's the process to clarify and develop the oil palm phenolics. Julia and her colleague, Dr. Hayes, like to call it palm fruit juice, which I think is a better marketing aspect. So from the vegetative liquor from the mill takes it in the processing, heats these empty fruit bunches. There's a high water content to that. The temperature of that vegetative liquor coming out of that mill is between 80 and 90 degrees centigrade. This does two things for us. It deals with the potential microbial burden in a product, so this basically is pasteurized. And two, what we're really selecting and dealing in this process are phenolic products that are reasonably heat stable. So this then goes into a chiller. This chiller is cooled and cools our product and process line, and then we use 3 steps of unit operations for making a final product. And our standard in the beginning here is a 1,500 ppm gallic acid equivalents. Now, as you can see from this very simple diagram, what are the challenges we have? First of all, we have a challenge on the raw material. Clearly, it's going to vary from season, whether it's dry, wet, plantation location, mill location, etc. But on the end of this, we need to come out with a standardized product because we can't sell OPP from mill A versus mill B versus mill C and not have the same product identity. So we have to characterize both what's going into this in terms of the supply and its properties, but most importantly, what is the product coming out of this very simple unit operations. So we've spent a lot of time on characterizing the OPP product coming out, and I'll show you that in a minute. But in addition to that, we spent a significant amount of time doing the quantitative analysis, the material balances on the flow of product through this system. And the reason we've done this is we have to develop a strategy to determine the optimal size for a first phase commercialization of this, so we need material balances, primarily what we focused on, and then eventually we'll have energy balances. We've developed strategies to put the quality control and quality by design parameters in this operation. So, it turns out, in a magical sort of way, there are 5 major phenolic compounds in OPP that turn out to be the signature of this product. Now I'm showing you baseline separation. I'm showing you these 5 fingerprint molecules in the green, as you see, which we spent a considerable amount of time and effort. I want to assure you this was not an easy problem to solve. Because one, we have 3 new molecules we'll show you isolated from the oil palm, and then the individual identification of this, and then thirdly, to develop a baseline separation. I won't show you what the compounds of some of the other peaks, because they still are in some developments in IP generation. So the 3 key molecules are the caffeoyishikimic acid, and I'll show you the structures and the properties of them in a minute. But we analyzed with the colleagues here at MPOB samples from 10 different mills. You can see the key 5 fingerprint molecules. The highest are the caffeoyishikimic acid components. The standard deviation is to be expected reasonably high, but what we've been able to show is the fingerprint holds true. What varies is the absolute amount, and then we developed a software program to blend these materials from different mills to a standard composition as we go through that. So we're fairly confident we can standardize the phenolic print into a design product that we need. Now, so that was the tremendous effort on the HPLC analysis, coupled with a lot of UV and other analytical tools. But to identify these products, we had to go to preparative HPLC fractionation processes. It means our colleague Sam, who is a brilliant chemist at MIT, he's a brilliant emotional chemist at MIT, identified and isolated the 6, 7, and 8 number peaks by collecting hours of samples from a preparative HPLC. That led to the signature compounds of caffeoyishikimic acid, and you can see they are derivatives of shimic acid with this caffeoyl group associated with them. Other studies now done by other groups here in Malaysia confirm these molecules. I'm not so sure they've been as rigorous as we have in those processes, but they've been confirmed now, and we clearly are confident in those. And then I show you the structures of procatachoic acid as well as parahydroxybenzoate. When you see this and send this to somebody like a flavoring company, what they become also very interested in is the fact that we're producing natural antioxidants that could go into potentially natural food ingredients. What is the structure of this? This is the first report of caffeoyishikimic acid in oil palms, 3 isomers. We did the mass spec, we did the NMR, and the carbon-proton chemical shifts to get these exact structures. Again, not a trivial task. We had a collaboration with a local university to do this as well. Now, this shows you that this antioxidant capacity of OPP is quite significantly, that's the red bar here, and we just show you from the literature the antioxidant numbers reported for a variety of products being sold as antioxidant accelerants or foods and beverages with antioxidant properties. We have to confirm some of these numbers, but most important, it tells us, look at the flexibility we have in this product as far as dilution is concerned and formulation. We've done limited toxicology studies. One of the first we've done is to use the brine shrimp assay. It's commonly used to measure exotoxicity. Oh, okay, that's on. Okay. The yellow means I'm consuming time, right? Okay, I'm still in the yellow zone here. I think it should be green, but okay, so it's not running the clock, so okay, I'm all right. It measures the lethal dose, which kills 50% of brine shrimp. This is used extensively in industry to measure ecotoxicity and product toxicity as well. This is our first studies done with this assay. OPP buffered tells you it's really non-toxic at very high doses. You see grapeseed, Nescafe coffee, and OPP is better than those in its standard average form. The important piece of information to see here, it's less toxic than Diet Pepsi. When I'm in Malaysia, people count how many Diet Cokes and Diet Pepsis I drink, so this convinces me to keep on moving. We've also done in vitro cell lines, 3 animal species, and you'll hear this presentation in a few minutes about the phase 1 human safety clinical trial that's just been completed at MPOB. Histology has been done with mice that were fed OPP at 1,500 gallic equivalents for 6 weeks, and pathologists cannot tell the difference between treated and untreated control mice. A very important study done for 3 generations, fed 22 weeks in each cycle, was genetic studies to study potentially formation of various types of teratogens, and you can see in these data that we don't see significant pathological differences in this type of analysis as well. So an interesting thing is we don't find OPP or palm butter soup consumed in the U.S., but it's been consumed in Africa for centuries. First reported in 1890, more recently in 2005. No data on consumer availability in the U.S. There's been 2 surveys done on dietary intake of oil palm fruit in Ghana, and you can see the Article 1 and Article 2, the average food intake over a period of time and the probability of a person taking a food component containing oil palm fruit. You can do calculations on that, and we come to the bottom line calculation here that we're dealing with daily intake of OPP between 190 milligrams and 540 milligrams per day per person. As many of you have listened to in this conference, we're dealing with oxidative stress and oxidative damage, reactive oxygen species, and we feel that Phenolaeis products, OPP, plays a major role in controlling oxidative damage. We've done the following studies. We've primarily looked at all measurement techniques readily available for reactive oxygen species, and we can correlate between any assay. We then also have done in cell culture microarray analysis, looking at selective expression of several genes. An interesting one is heme oxygenase, and we've also confirmed by quantitative PCR. What's exciting about these results, the activation of the genes is not large, it's only 2-fold. It also peaks at 12 hours and goes back to normal in 24 hours. So we think there's a process here by which this is not a cumulative effect, but a response. We demonstrated clearly that we changed the ratio of glutathione to the GSSH ratio, and then we've also shown that we induce these enzymes of heme oxygenase. Let's talk a little bit about the global market opportunity. For functional foods and drinks, it's expected to be over $130 billion by 2015. It's astounding that the antioxidant market is predicted to be $86 billion by 2016, and I think it's about $65 billion now. Market growth is spurred by demand for innovative products, increasing in health and wellness concerns. This is a major issue in the U.S., as the U.S. has to drive down health care costs. So we have pharmaceutical companies forming new divisions in health and wellness. Coca-Cola has formed a joint venture with Sanofi on health and wellness. We also have the major hospitals developing health coaches to reduce the disease burden coming into the hospital. We also see disposable incomes rising in this part of the aging population, changing lifestyle. So what's our strategy is to manufacture and commercialize this multifunction oil palm phenolics for health and wellness, provide innovation in health by enabling preventive care and protective measures. I think this supports the modern trends in modern medical sciences. We have a strategy to interact with world-class scientists and engineers to establish and maintain the global leadership in this, and this is a Malaysian operation. We want to add value to the oil palm industry to create value from this underutilized, low-cost product. Strong and dynamic intellectual property, as Ravi says, there's been 20-plus patents in this field developed. And then we have this technology platform for green technology. And I think our long-term commitment is to improve the quality of life. Just to show you, our process as it stands now is optimized to take about 3 million liters of vegetative liquor, go through our production line, produce 1 million liters of product in a liquid form as 1,500 gallic equivalents. That allows us to develop 2 process lines, one for dried product, the other one for liquid drinks. That allows one to think about types of products that one can develop, from pellets to drinks to mixes, and what we've been playing with, how would they be dosed, the packaging strategies and so forth, and we're in the process of helping and forming a relationship with a marketing group to design these. So our commercialization strategy is we're forming and want to form a partner with a major marketing firm that has global reach. We're working on strategic alliances in nutraceuticals, medical foods, pharmaceutical companies very interested in some applications, fragrance. As Julia's beautiful data says, there's an opportunity here to reduce the glycemic index of food. We think it's this big opportunity for bakeries because that product was in the diet, as well as the studies on macular degeneration. So in summary, we have unique technology, we have novel structures, properties, we have patented process, we have the patents on the recovery of this from the palm oil vegetative liquor, entirely of Malaysian origin, which I'm extremely proud to be part of, organic solvent-free process. We think it's economically and commercially feasible, but it turns out the economics don't matter. It's important, but I think there's such opportunity here. The science will drive this to the commercialization. Where the science takes us is where we will have our products. So our approach is we mine and model a product development. We measure the data, we manipulate it, and we make a product, and hopefully we sell it. We're committed to development by quality by design, GMP manufacturing, biomaterial sciences in the area of materials for this process, formulation. There's big challenges in engineering the equipment. Very committed to a regulatory strategy, process engineering, supporting animal and human studies, in vitro and chemical, biological, and we're very committed to chemical engineering. Our strategy is to take this project and convert it into an engineering development strategy which can handle the challenges and the complexity of this problem. With that, I'd like to acknowledge my colleagues at MPOB who have been just fantastic to work with for a number of years, and clearly the Director General of MPOB who's been extremely supportive of our program and our interactions. That's the end of the show. Thank you.
Thank you, Professor Sinskey. Perhaps we'd like to have one quick question from the floor.
I have 4.28 minutes left. Remember, I didn't start late.
Yeah, sure,
Okay.
we can have more questions.
I'm just going by this.
Otherwise,
It's okay if you don't have any
over
questions.
coffee.
We can all have tea. I will not feel insulted if you don't have a question or comment. Okay. Thank you very much.
Thank you very much, yeah. Okay, we can now all adjourn for coffee, and we'll be back here by 4 o'clock for the second half of the symposium. Thank you.